I'm going to be doing construction proof of sine sum-identity. Our sine sum-identity is sine of alpha plus beta equals sine of alpha times cosine of beta plus cosine of alpha times sine of beta. To do this, I'm going to start by making a line. I'm going to call this line AB. I'm going to draw another line, rotate upwards, and call this line AC. Draw one last line, and call this line AD. Now we're going to call this angle CAB alpha, and this angle DAC beta. We're going to draw a line from AD perpendicular to line AB. Because that line is perpendicular, we know this is a 90-degree angle. So we're going to call this point E, line DE. So right now we can already notice that sine of alpha plus beta, because that's the left side of our sine sum ID, sine of alpha plus beta equals DE over AD, because that is sine. Sine is opposite over hypotenuse. And sine alpha plus beta is this whole angle. So this whole angle's opposite is DE, and the hypotenuse is AD. So I'm going to write sine of alpha plus beta equals DE over AD. And we're going to draw another line from D perpendicular to line AC. We're going to call this line DF. And I know that this is perpendicular. This line is perpendicular to AC. So this is a 90-degree angle. I'm going to draw another line from F perpendicular to line AB. There to there. And we're going to call this point G. So now we have line FG. And we're going to draw another line from point F perpendicular to line DE. And we're going to call this point H. So right now, we can notice that line HF is parallel to line AB. This means that line AC is transversal with both lines HF and AB. That makes line angle CAB and angle HFA congruent angles. This is also a 90-degree angle, and so is this. Because this is a 90-degree angle, we know that angle HFA is complementary with angle HFD, making HFA also congruent to angle HDF. Now, we're going to remember that sine of alpha plus beta equals DE. Line DE is the sum of line DH and HE. But for the sake of this problem, we're going to use FG instead of DH, because FG is the opposite of alpha, and we're going to need that later. So now I'm going to substitute this for DE. Now we're going to separate this fraction. So we're going to make that line DH over AD plus line FG over AD. Now we're going to multiply these two fractions by judicious forms of 1. We're going to multiply this fraction by line AF over AF. And we're going to multiply this side by FD over FD. Now, multiplication and addition are both commutative properties, meaning we can interchange them. So, sine of alpha plus beta equals line FG over AF times line AF over line AD plus line DH over line FD times line FD over line AD. Now these fractions can get a little confusing because they're just lines. We don't have any number to value these. So we're going to put these into things that are a little more familiar for us. FG over AF. FG over AF. This is also alpha's opposite and hypotenuse. And we know that opposite over hypotenuse is sine. So that is sine of alpha times line AF over AD. And this is beta's adjacent over hypotenuse. And we know adjacent over hypotenuse is cosine plus line DH over line FD. Now, because these three angles are all congruent, we can also call this angle alpha because it has the same measurement as alpha. So line DH over FD is alpha's adjacent over hypotenuse, and that's cosine times line FD over AD. This is FD over AD. This is beta is opposite of our hypotenuse, making it sine of beta. And that is messed up. That is our sine sum identity.